Hi everybody, welcome to the Python Basics workshop. I'm Kayla and I'm going to go through the first part of the workshop. So real quick, if you want to check in, you can check in at this link or just scan the QR code. So in general, I'm going to go through what is Python and setting up your machines. And then Jessica will go through the Python basics, and then Alan will go through the demo at the end. So what is Python? So Python is basically just an object-oriented, high-level programming language, and basically has a lot of built-in data structures, so it's really useful for pretty much like everything. It's very diverse. So some strengths of Python is that it's able to import packages. Packages could also be the same as like libraries. So for example, Jessica will be going over the pandas library in the rest of this workshop, and you'll see how that works with Python. Another strength is that Python has really easy syntax, which makes it really easy to learn. Additionally, it's very popular in data science, and I'm pretty sure many data scientists actually recommend using Python because it's just like really powerful. Additionally, it's very dynamic, and then again, it's open source, so there's a lot of free code online that you can look to reference and also use. And then here's sort of like a quick picture showing like other benefits of Python, like deep learning. You can do machine learning, predictive analytics, exploration, data analysis, and more. So some weaknesses of Python is that it is kind of slow compared to other programming languages. Also, it's weak in mobile development. It isn't very good at making like mobile applications. Additionally, memory consumption is pretty high, so it's not able to hold a lot of memory, so that's another weakness. And then here's a picture of like some other disadvantages. I mentioned the first two, and then there's also some design restrictions, and in like databases, it's underdeveloped. So how is Python used in industry? In industry, Python is usually used to build web applications, analyze data, manipulate and transform data, and also machine learning. And here's another picture of how Python is used in the IT industry. I mentioned web and internet development, and there's also scientific and numeric computing, software development, and a bunch of other stuff. Especially for data science, Python is very widely used. So basically, Python is just a really useful skill to pick up because it's pretty much applicable in most IT jobs. It'll help you with like data frames and like data sets and stuff like that. And then as you can see from this picture, Python is very useful, and it's very like widely like wanted. Like industries want you to have Python as a skill if you want to go into technology. So the next part is I'm going to go through setting up your machine with Python. So downloading Python is pretty simple. You can go to this link here and just click download pretty much, and just go through that download process. A quick note is that Python 2 and Python 3 are different in the sense that some packages don't work on Python 2, but they'll work on Python 3 and vice versa. So choosing whether to use Python 2 or Python 3 really depends on what you want to do for like what you're working on or like your project that you're using Python for. But you can download both Python 2 and Python 3 onto your computer, and you can just switch between the two depending on which one you need to do your work. Also, when you're going through installation, you should add Python to path. There's a checkbox at the bottom when you're going through the installation process, so make sure to check that box. Another way to download Python is through Anaconda. You can go to this link and just download Anaconda, just like you would normally for any other application. But if you already have Anaconda installed, then you can update Anaconda by putting these commands into your terminal or your command line. So this is what Anaconda should look like once you open it. This is the Anaconda Navigator, and these are some of the apps or like software that comes with it. So you can basically launch like Jupyter Notebook or like other applications that comes with it, and basically you can just use Python with it because Python comes installed with Anaconda. So another thing to take note of is environments. Environments are really good for like specializing for one topic, like customizing your packages for one project. So like, for example, if I was doing a project and I only wanted like the pandas package for that one project, then I can make an environment and only have the pandas package and basically write my code in that environment so that everything will be like pretty much set for me. And you can have multiple environments so that for each project you can have like customized packages for your specific project. And yeah, again, just like I mentioned, you can create a bunch of different environments with the packages you need for different projects. And then within your IDs, you can specify the environments that you want to work in. So like here's an example of like what an environment would look like. So you can see here that you can see, let's look at Python 3.7.1. You can see that there's like the Anaconda 3 and then /bin/Python. So that's pretty much the base Anaconda environment. But then as you can see below it, there's the CSE 163 environment that you could create and you could work in basically. You can click that environment and work within that environment. So here are some common IDs that Python is used in. PyCharm is really popular. Visual Studio Code is also very popular. Jupyter Notebook is very commonly used for kind of like documentation. This is not like you're just archiving stuff, but like because Jupyter Notebook doesn't have like autofills or anything like that, so you kind of have to type out every single line and it won't like pop up suggestions for you, unlike PyCharm or like Visual Studio Code. But Jupyter Notebook is really good for like showing your work and having like other people kind of scroll through all your work and understand like what's going on. Spider is another popular one. Spider comes with Anaconda, but also Jupyter Notebook comes with Anaconda. Atom is also really popular. And then there's a bunch of others. So it really just depends on like what your preference is and like what sort of IDE you want to use. So that's the end of my workshop, or my section for the workshop. I'm gonna hand it off to Jessica next. Bye.
Hi everyone, we're gonna learn on the basics for Python. So first we're gonna learn about different types. The first type we're gonna learn is bool. Bool is also short for Boolean, which is basically whether it's true or false. And it can also have logical operators such as and, or, and not. So we're going to look at this example. Here we define two variables, b1, b2, which hold the value false and true. And when you do b1 and b2, it will be false because both of them have to be true in order for this conditional to be true. Same as this, it will be true because b2 is true and it just needs either or to qualify. And the third one is not b2 and b1. So not b2 will be the opposite of b2, which is true, so it'll be false. So false and false is false. And then the combination of these are true, and then not is true. So you can get bools by comparing numbers. For example, if we set a variable x equals to 3, we print x is less than 4, we get true. X3 is greater than 5, that's false. 3 does not equal 2, that's false. Next, we're going to learn about casting and the types that Python has. So every piece of data in Python has a type, and you can convert between types by casting. So example, we have a variable called that is 1.4. When you print it, prints out 1.4. If you cast it to an int by this, you'll get a 1 because int doesn't have any decimals in it. Same as this, 1.7. If you print it, it's going to be 1.7 because that's a float. Otherwise, when you try to cast it to an int, it gives you an error because it doesn't make sense to convert a string to an int. So you can commonly use types such as int, float, boolean, and string. You can use type x to find x types. A while loop has a condition and a body. It executes the body repeatedly until the condition is false. So if x equals to 1, we have a while loop, where x is less than 100. What you have to do is print out each variable in the loop. So, for example, you print out 1, 2, 3, and each time in the loop, you increase it by a multiplication of 2. So 1, 2, 4, 8, 16, and then you keep going until you break the loop, which is at this point, and then after the loop, you want to break out of it and print 128. So important, Python uses indentation to determine what belongs inside the loop. Very common beginning error. So you want to make sure that if you ever received an indentation error, unexpected indent, you want to make sure that your indentations and stuff with the loop are correct. Next, you want to we're going to be looking at for loop. So if you already have experience with Java, for loops basically work exactly, actually look pretty different, but they basically act the same. So for here, a loop has a body that repeats for every value in the sequence using a loop variable to track the current value. So compared to Java, where you have like for int I equals 0, I is less than, 5, and then semicolon I++, we have something for I using this keyword in within the range of 5, and then you print out each variable within that loop. So for example here, just like Java, it is a 0-based index, so you start off with 0. Oops, sorry. 2, 3, 4, and then after the loop, we'll exit the loop and it'll be after loop 4. The many use of range A between 0 inclusive and A exclusive. That's why we don't see the 5 come out. So for example, range A to B between A inclusive and B exclusive. And then same thing with range between A inclusive, B exclusive, and steps by C. So conditionals. You can use conditional statement to have your program execute different branches of code based on test conditions. Keywords are if, else if, and else. For example, if x equals to 14, if x is less than 10, you want to print A. Else, if x is greater than or equal to 13, you want to print B. Else, print C. So just like if and else if cases and else in Java. So what value of x falls into the else case? So for this, You want to make sure that you are printing 10, 11, and 12. That would fall into this case. The following case, because it is between 10 and 13, whereas these cases are less than 10, and this case is greater than 13. Also, another thing that's important within Python is learning how to call functions. So a function is a named procedure with a series of instructions that can be called in your program to execute those instructions. So in order to call a function, you want to have a function name and the parameter. So Python has many built-in functions that you can call and you can use in your program. Here are some types: print, range, casting, int, float, bool, and string, and also math, such as absolute, max, min, and sum. A function can take arguments to pass information to the functions and may return values. So for example, here we have a function called min that has 4 and 7, and also a max, which contains 5 and the minimum between 4 and 7. So x will be 5. That is because the return values from here is 4, and the maximum of 5 and 4 is 5. Also, another very important thing to learn is how to define your own functions. So for example, say that there is a function called greeting that prints the word hola. So we define arguments between parentheses and also use return statements to return values. So for example, here we have a function called mean that has value a and b, and then you want to print calling mean with a and b, and you would return it by having a plus b and then dividing it by 2. So for example, main, in the main function, we have a variable that stores the return values by mean, so 4 and 5. So here we have 4 and 5 are the passed in arguments, and it will give 4 plus 5 divided by 2, which is 8 if it was an integer. And then we will be able to print the values from here. So next, we're going to learn about different Python data structures. So we're going to cover 4 different data structures. First one is lists, which has indices, and this can be added and removed at any place. Second is sets, so no duplicates, fast membership queries, and no order. Third is a dictionary, and it's like a generic list that can hold any values as keys, and keys are unique. Values are not. Tuple, immutable list used for multiple returns, can unpack. So first one, we're going to look at strings versus lists and see what the differences are. So here's the example of a string. So here you have a string and the a function that gives you the length of the string, which is 11, and the indexing. So for example, since it's 0-based index, it will give you 1. And then since if you want to get the last character, you want to do the length minus 1, which will be d, and you want to loop over it by going from, for I in range of length of s, so that means you'll go through the entire length of the word of the string hello world and print everything out. And then this is also basically the same thing. And then this is a list with 3 strings, and likewise, if you do the length, it will return 3. Length of 1 will give you say, since 0-based index. Length of the last one will be wolf. And then also looping will be in the range of length L. You want to go through each one. It'll be dog, says, and wolf. And then for word in L, you want to print out word, which will go through and also print out dog, says, and wolf. So here's another example on list comprehensions. So here we have squares, which is a same things here, where this symbol is also known as exponential, so it's I squared. So for I in the range of 1 to 11, if it's ever equal, if the modulo by 2 is ever equal to 0, then we keep going, otherwise we skip. And so we put all this in a list. Next is a set. And so a set is a data structures that are highly optimized for membership queries. So if X is in set, it is very fast. And acts a lot like list, but it does not allow indexing operation, but does not allow duplicates. So for example, set methods make an empty set, and then also when you want to do, if you want, there's other methods such as adds, remove, and clear, which adds to it, removes it, and also deletes everything from the set. Then the next data structure we're going to be learning is called a dictionary, similar to also known as a map, kind of like what we see in Java. So it basically has arbitrary data as indices, such as keys. And keys are you want to make sure keys are unique. You can't have duplicate same keys, and also values are not. So for example, here you have a map called D, which stores the variable key of A and B with 1 and 2. So you want to print out the map, it'll give you something that looks like this. It's basically also a fancy list, just most syntax is pretty familiar to, similar to a list. There's also the last data structure we're going to be going over is called tuples. It's a lot like list, but it is immutable. That means it cannot be changed. So once you've defined it, nothing can change it. So here we have a tuple which stores 1 hello 3.4. So if we print it, it will print out all the following information. When we print T 0-based index, it will be 1. T1 equal goodbye, this will give us an error. That is because it is immutable. It cannot be changed. And then also you can unpack the tuples to get the content. So for example, you define 3 variables, and it would store 1 in A, hello in B, 3.4 in C, and print out hello. Once you do this, print out the second one. Next, we're going to learn about Panda libraries. One of the basic data type from Pandas is a data frame. It is essentially a table with column and rows. So for example, here's a data frame that has different columns and different rows. It's basically similar to a table. Here are the columns, here are the rows. So a series is like a one-dimensional data frame. It has no columns. It has an index, and it's basically a fancy dictionary kind of hybrid. So for example, if we look at here, df of name, we get the following. And then we get 1, which is the name column, and then the row 1, which gives us Burma. There's also another thing in data frames called filtering. So we can use a bool series to select which rows from the data set. So first we define a mask, which is the following. So we have the data frame of the magnitude column, and we want to make sure that's greater than 5. So if a data frame of a mask is the following. So it will filter out the data frame to only contain magnitudes that are greater than 5. We could also use multiple filters with and, or, and not. So for example, here we have a mask for that is greater than magnitude greater than 5, and also a not symbol that has a day that is equal to 27. So it will make sure that the data frame does not have any days that equal to 27. Next, we're going to learn about location. This is how to access data in the pandas. So for example, series looks like this, data frame, it looks like this, location row index C and column index C. So an option for indexers is a single value, a list of values or a slice, and a mask or a column to select a value. So the next thing we're going to learn about is a group by. So in data frames, you could do group by column 1 and column 2, and then sum them up together. So for example, if we group by column 1, we're going to group A's together. So that gives you 1 and 4. We're going to group by B's together, so that's just this following row. And the second one, that is 3 and 5. So third, we're going to do apply. So what we do is sum up all the following things together, which is 5. Sum this is 2, 3 and 5 is 8. So you combine them together, which will be 5, 2, and 8. Next, we're going to do apply. So we have shown how to filter and group your data, but sometimes you want to transform your data. So it's pretty easy to change numerical data using the operators we learned last time, such as plus, minus, absolute, min, max, and etc. With strings, it is not so easy. So you get the data, you have the following name, you get this string, you can do a length, upper, apply, and apply my function. The last two pass a function as a parameter, so these following two. So basically applies the function to everything within that series. There's also another thing called sorting the data, which is also a very common task, and it is either for presenting or finding the top. So it's very easy in pandas. So in all of these, return a new data frame. For example, here we're sorting the values of column, and we can sort it by index. Yeah. If you want to find the top largest one, you could do n largest, which is 10, and then sort it by this column.
Hi everyone, this is Alan from Applied Analytics Club. Today I'm excited to give a demo on Python on like 3 parts. One is basic programming, the second is Python data structure, and the third one is Python library, which will focus on NumPy and pandas. The first one is working with number, and the second one is working with like data like CSV file. Okay, so let's dive into it. So first, let me introduce you some kind of Python types that you can commonly see. Mostly, we can categorize these as integer, string, boolean, and floating point number. So as you can see, in Python, we don't really need to declare our types. We just need to assign the value to its variable. In this case, this is an integer. And we can also like declare other kind of data type, like a floating point number, or like a string. For example, like the string of hello. Or you can also assign like Boolean value, like true or false. And I'm going to introduce you, especially in numerical types, that there are these kind of special operations of divide. In this case, I want to make it integer, so it's easier for you to see. So when you print it out, you can see like the normal divide function will catch your type into the decimal point, which is like the floating point number, while the double divide function will do an integer division. So now, let me introduce you to some other programming constructs, such as loops and conditionals. First, I'll teach you how to do like a conditional statement. In Python, you do this kind of similar to other programming structure, but there are no parentheses or curly bracket. You simply type in your commands and do a colon. When you press enter, it will automatically indent for you. So in this case, if we call this, if it's bigger than 6, it'll print out X. And if it's not, we'll print out Y, for example. In this case, it'll print out Y because X is 5. So now, let's move on to loops here. Like other programming language, Python also has 2 types of loops. But Python abstract this concept like in a really high level. So, for example, in this syntax, we're running a for loop on some kind of range function with a number 5. In this case, the range function specify like a series of number from 0 to this number exclusive. So in this case, for every I in the range 5, we'll print out I. So range 5 will create a series of number from 0 to 4. And actually, range function can have several other parameters. We can pass in the starting parameter, which is inclusive, and also specify the step size. For example, if I want to increase my step size by 0.5, as you can see, okay. Seems like floating point number doesn't work, so as well, advance by 2 at a time. So this means that the range will start at 1 and create a sequence at a step size of 2. So first is 1, then second is 3, then When a +2 is equal to 5, but notice that the second parameter is exclusive, so 5 will not be printed out. There's also another kind of loop called for loop. In this case, this is a similar idea, but normally you have to specify your index at the outside and do a manual encryptment. And your conditions is the same, and the syntax for column and indentation are the same as well. Notice that it won't work unless you got the correct indentation, so make sure that it was indent correctly based on your syntax. Now, I'm gonna introduce you how to define function using Python. In this case, use the def special command and put in your function name and parentheses with the argument you wish to pass in, you wish the client to pass in. And same old colon indentation syntax. In this case, it will print out the Fibonacci, the nth number of Fibonacci that you pass in. And if you want to call in the function, you can also do it by, for example, we use, there are common function built into Python. For example, choosing the minimum number between three numbers, for example. And that's printed out. So as you can see, the function returns a value, and you can print that value out. So in this case, we can actually return a value here, or return this one. So by default, you have to specify this to print it out. Now, I'm going to also to introduce something extra called string concatenation. For example, if you want to connect two strings together, let's say hello and there. So if you want to concatenate two strings together, you use the add operator. And notice that if you're concatenating with a number, it won't work because X is of integer type, but S is of string. So in this case, you simply cast your X into a string and it will work. Let me go to the second part of our demo, which is introducing to some Python data structure. The common data structure in Python are four. The first one is a list. A list is something like an array if you write in other programming language, and you specify the element using curly braces. If you want to define an empty list, you can just use the curly braces like this. So by printing it out, you can see this is exactly the same. In Python, they use zero-based index. So the first element is 0, the second is 1, and so on. There's also a really convenient syntax of the negative, which count your index back from the last one. In this case, L indexing -1 will return C. And list is able to be mutated. So if you specify that you want the index 2 to be D, then it will change it to ABD. Commonly, we'll also want to use loops to work with these kind of data structure. So this is really simple. Just specify your element. Actually, you can do this. Specify the range and pass in the length function. And print out less than I. This is the most common way that you'll work with. You might work with this in other kind of programming language, but Python gives something similar to like a for each loop in Java, in which you can just access the value directly from list and print it out like this. Let's move on to the next data structure. This one is called a tuple. It is like a list, but it is immutable, which means if you are trying to index to a specific thing, it will cause an error. I mean, if you all try to assign a value to like a specific index, this is not allowed. And you're working with tuples, it's really simple. You can also unpack the tuples by assigning the value to tuples into like variable. By printing out a variable, you can see it is simply A, which is just tuple index 0 and so on. The same concept can also be used in tuple by using the for loop to access each element and print it out. The third kind of data structure is called a set. Set, you specify using the curly braces, or if you want to define a set, you can also use the set function like this. Basically, set is something, a data structure that won't repeat itself. So if I declare 1 to be twice, it'll only print out 1. And set is like a really efficient data structure in which it didn't have any sequencing, so you couldn't really access like a specific element in here. You can only add or remove, I think, but I'm not sure. The last data structure is called a dict. A dict is commonly like a map, like you map a certain thing to a certain value. In Python, it provides like a really handy syntax in which your index is like kind of the index you have in list, but you can specify in whatever you want. So in this case, index is a string, your value is also a string. But notice your index don't have to be of the same value. I can also do this. And this will also work. Now you have the basics of Python. We can go into some deeper concept like a Python library. In this case, we're going to introduce you to two simple libraries. One's called NumPy and second is called pandas. First, NumPy is commonly work with numbers. For example, you can declare an array, which is something similar to a list. Oh, okay, I didn't load in. And you specify your array. NumPy also provides a really handy function which allow you to specify that create a number similar to like range. But it's called a range, which creates your number from 0 to 15. And you can also reshape it to make it like a matrix by passing your row value and your column value. Also, in NumPy, you can have these kind of function which create a 3x3 matrix of 1. Python is really smart. If you do like a single NumPy array and divide it by 4, it'll automatically divide each one by 4. So this is called element-wise operation. And you can also access like a specific subset of your NumPy array by indexing into the first one. This is called slicing technique. The first index is inclusive, the second is exclusive. And you just specify the row and column. And NumPy can also use something called a mask. which you pass in your data and compare the value, the desirable value to every single element in your data. In this case, I specify a variable called bigger than 2, which compare each element in 1 and see if it's bigger than 2. So automatically, it'll return a matrix of all false with the same dimension. And you can use this mask to filter into your NumPy array and give you nothing because nothing is bigger than 2. But if I change it to 1, oh wait, I think I divided by 4 or something, maybe 0.1, then it'll print out all true. In this case, Python also provides another handy library called data frame. This is commonly working with CSV files or something like Excel file. But here, I'm just gonna manually declare a data frame here as a demo. So your data frame will look like this. Each one is a column, and each column has a specific value. If you want to access the value in the column, you can use the squarely bracket notation, which access your ID. For example, I want to access my ID. Return your series of ID. Notice these kind of data structure in Python is called a series, while the entire thing is called a data frame. Python also provides something similar to NumPy, in which you can also max if you want to find the ID between a certain number. In this case, I want to find the ID between, let's see, 2 million and 3 million. You can do this using the single AND operator, which compare your element. I think element by element. So if you do this max, it'll only return a single row with ID of this one. But actually, sometimes you might want to access both rows and columns. You do this by using the .log function. So I want to access only the name column and pass in the kind of rows I want. It'll simply print out this one. So let's conclude my simple demo on Python. Hope you have fun working with Python and let us know if you have any questions. See you next time.